Hello, welcome back. This is part 2 of making magnificently good graphs. Here we'll cover the R portion of this special topics talk. I'm Dr. Mark Williamson. Let's jump into the overview here. We'll be looking how to make great looking graphs in R, primarily with the package ggplot2. So how the format I've set up is we'll start by making very simple graphs, and then looking how to upgrade them by modifying the various elements. Things I'll be kind of color coding going through would be labels, axes, shapes and colors, dots, lines, and text, and then sort of an other category. So if you've not taken the pre-test for this section, I'd ask you to just take a moment to take that here. If you'd like to follow along on your own, the R code that I'll be using is available here. And then if you just want like the slides, not the video, you can get the slides in a PDF version here. And now, please stay tuned for an extra special treat I have for you at the end when it comes to R. All right, let's jump in. So to set up here, I would suggest using RStudio or like a script in a Word editor, like Word or Text, like a Notepad, whatever, just to like have code you save. And then this is what I use here. This is RStudio. I really like it because it has built-in text editor here that I can save, and then you could run the code down here. Graphs will show up here. It's a really great interface. Now, before we get started on this, you'll need to install packages ggplot2, mass, gmodels, and dplyr if you haven't have them already. The reason we're using ggplot2, it's a structured way to create great graphs. What they use called the grammar of graphics is sort of like a much more structured way of doing graphics than most of R does. And if you want, here is a really great link for a reference sheet, like kind of a cheat sheet, as it were, for ggplot. In fact, I have it like taped up on my wall here, that I use it that much for ggplot. Okay, so let's jump right into the first type of graph, histograms. So we'll start with a basic histogram, and whether you consider it through chemistry or culture, this will indeed be very basic. So all you need to do with the R code is this here. And this is the format I'll have for all the plots. I'll create an object, so h1 histogram1, and then set whatever code here, and then I'll call it through just typing it out here. So really all that does is create this. So there's a data set called Nile, and all it has is a single variable that is Nile, I think, flow rate. We'll see that more detail later. Now, if you want to do the same sort of thing in ggplot, it's a little more work, but here we go here. So how ggplot works is you start out with this ggplot function. You have to tell it what data set you're using and then set your aesthetics. Typically that's like your x, y variable, your fill variables. Here all we need to put is our one variable here, Star Wars height. And then after you make the ggplot, you have to add whatever other elements, what are called geometric functions. So here we're going to use geom histogram. And you could leave this blank, that would make the simplest ones, but I just filled in a couple pretty common ones just to get us a feel for that. I set the number of bins, so how many, I'll actually just show you here. The number of bins, the fill color, because otherwise the default's kind of weird, so gray, and then the color. So fill is what goes inside, color is the outside, so the border, I guess you would say. So this, you see here, with a little bit more code, you get a much clearer histogram, I think, or at least a lot more customizable. So this is our first of what I would call a stat hacks, is use ggplot and get used to using ggplot, because then once you get kind of the grammar down, it's very useful for any sort of plot you want and customizing it. Let's look at another sample in ggplot example. We'll use a 2-sample histogram where we have a x variable, a continuous variable that we'll measure along the axis, but we want to split it up into 2 groups. So we'll use the same height we did in the Star Wars characters histogram from 1, but now we'll also add another aesthetic called fill. So that's like different fill means like to have the different colors. So we'll do it by gender. And here's our histogram. Again, very similar to this. There's a couple things we add to. We need to add an alpha, which is also known as like how transparent it is. And then we have to a position of identity to make sure it lines up. It's sort of a default thing. And then we'll also do a scale fill manual. This is how we can manually change colors. We filled it by gender, and now we're going to tell what colors to have by having this value statement, and then it's pink and blue for male and female, and then we'll finally call it. And here we go. We see it's very similar to this one, only the bars are colored by gender. So those are ways to do some pretty simple histograms. Now that we've done the basic histograms, let's upgrade them. So with the basic histogram, not in ggplot, there's a lot we can do. I've started to color code these additions I'm making here. So let's start with the yellow and labels, so I can label my x-axis a little bit nicer. I'll pop this up right now. I can, if I don't want a title, which a lot of graphs for, say, publication, you don't want a title, you can just have main and then make it blank, so there's no title here. Moving on to our axes, we can set our axes in a different way. So this one sets the limits from 0 to 1500 instead of our initial one was lumped around like 400 to 1500. So if you want to have a different limit of your axes, you can do it that way. Then with like kind of colors and shapes, if the way to do number of bins in the basic, it's called breaks. So we have 6 breaks here. 1, 2, 3, 4, 5, and 6. And then for dots, lines, and text in purple, we can change the color of our actual bars to blue, and then border is black. So we can change the color of both of those. And then some additional things we can add after we make our graph. We can add a rug plot. That's this sort of density lines down here, and then a box, which kind of makes a nice box around everything. Okay, we can also upgrade a lot of things in ggplot. So first, one thing I did here, I'm not going to go too much detail. Essentially, I made a data set that creates a normal distribution for our data. And then I do our ggplot, geometric histogram. And then here is where I'm going to actually add some aesthetics to create a density rather than frequency histogram. And so same sort of thing here. I'll pop this up here. This gives me all the colors and kind of bins. But then now we see here that this is a density, which is important if we want to have a density line, this normal histogram. So then, if we want to, in ggplot, if we want to modify our labels, we just use this plus statement. Anything, each statement has a plus sign after it. So ggplot plus histogram plus our label statement. So we're just going to change the x labels to character height. Then a plus. Then we're going to, if we want to change the axes of our x-axis, we do x continuous, and then breaks will give us, you can set specifically what breaks we want, what labels. So we have 50 to 300 here. And then finally, geometric line. This is another geometric function, and this is taking that data set I created here that essentially makes this nice normal distribution curve for our data set, and we colored it red. So there we go. Now looking at the 2-sample, there's a lot going on here, so let's dive right in. I'll pop up this again. You can see here, this is all pretty standard stuff we've already kind of done. But then in our scale fill manual, last time we had the values, but we could also change the name. So now we have this updated just to be capitalized gender. And then also our labels within this fill color, because we filled by gender, we capitalize them as female and male, so we can tweak that, make that a little cleaner. Again, we have our label statement where we can change not only the X character height, but the Y, and change that to a capitalized count. If we want to change our X continuous, again, we can set our breaks, our different tick, where our tick marks and labels happen. And then there's another thing here, we'll add it then, plus a theme here. That kind of just sets a lot of times the background, kind of how things, big picture stuff. So in here, we have the legend background, element reactor color black. What this whole thing is doing here is creating this nice white background and then this border for our legend. So that's all the legend, and then we set up the legend position. So now we see it's up top here. You can have it top, right, left, bottom, and so forth. But I think this looks the best here. So you can modify the legend in a variety of ways. Okay, we're done with histograms. Now with that, I have a little exploration section for you. Try creating on your own a 2-sample histogram of Star Wars characters masked by gender. So we have here the data, this was height. You can do the same thing, only with mass. And there are prompts in the R code, if you're using that can help you get started with that. Let's turn our attention now to box plots. Like histogram, box plots can be created pretty quickly, and often they're not actually used for publication. So doing something like these basic box plots I've been showing, of basic histograms, might be actually more preferable than having a little fancier, more work involved. So that's why I'm kind of showing you both. So to do a box plot in the basic version, you can use this function box plot, tell it the data set, and then there's a couple of different ways to tell it what variables are what. I like this sort of equation notation where you have the y variable and the x variable, where in this case the y variable is going to be a numerical variable, and then the x variable is going to be some sort of category. So these are cabbage heads, weights by different cultivars. To do a similar thing in ggplot, we'll take a look at a different data set. Once again, we'll have our ggplot, tell it the data, tell it the aesthetics, so our x and y variables, and then simply just this geometric function, geometric box plot. And it'll do something like that. We have these different types of feed by weight. Now to do a two-way box plot in ggplot, it's not much harder. I'm going back to the cabbage data set. The only thing we need to add is we have our y, our x, but we need to have that fill, how to differentiate by color. So we'll fill by cultivar and make geometric box plot, and boom, what we have here. We have x variable is date, y variable is now vitamin C or ascorbic acid content, and then our different cultivars by color. Now there's a lot we can do to upgrade these. So with the basic box plot, you can add things like X label, Y label, and those will customize our labels here. We can use this color to have specific colors. So we have green and purple because, well, that's the colors of cabbage, I guess. So that's why I use those. And then of course we can set like limits. Now here we set them from 0 to 5, kind of clean that up a little bit. And then we plot it. Now, a box plot in ggplot, you can do a lot more as well. So here is what I've done with the chick weights. So first of all, let me show you the plot so you see what we're doing here. So one thing I didn't like about the basic box plot in ggplot was that the error bars were kind of like, didn't have these whiskers on them. They were just like straight, like this. So what I'm going to do here is I start with this function stat box plot, which is going to generate error bars. So it just has these whisker error bars. But since ggplot, kind of think of it as like each line can like paste another thing on top. So if we start with here, we have the error bars on here, but then we go on to the next line and then we slap a box plot on top of that. And then that will give us the boxes. And so we can do a lot here. One thing here I decided is I have some outliers generated. I can change a lot of their features. So I change their color to red, their shape to these diamonds. There's a bunch of different shapes and they have numbers in R. So 18 is this filled diamond, and then the size I changed it a little bit. And then if I want to change the fill, so that's the different colors, I manually change these to kind of more, I don't know, feed type colors. And then I decided that I didn't really want a legend, so I can actually tell it legend position none, and it will suppress the legend. Okay, so let's look at our two-way box plot. I'll pop it up here. And so we got a lot going on here. It's pretty interesting. So we have our ggplot, our box plot, and then also I add this stat box plot again so I can get those nice kind of box and whiskers. Then I'll fill with green and purple, change the labels, both of the actual label names, and then also the what they're called. Then also for these are the X and Y. Sorry, this one up here was for the legend. And then I want my X variables. They were like D16, D17. I want it to be a little clear that they're days, so I redid the X-axis so it's day, day, day. So that looks a little cleaner. And then now here, I wanted to do this dot plot on top, stuck on top of it. So what I did here is I do this geometric function, geometric dot plot, set it by bin axis Y. That's just these things are just sort of default stuff you want to set up. But then I can change the size, which I did to make them a little smaller. And then this is the really important part, position, is I want to dodge the position, because if I don't have this, they'll just all plot up on this part right here across date, but I want to spread them out across the cultivar. And so sometimes you have to kind of tweak this a little bit to make it line up well enough. I think that 75 seemed to work well enough. So that's how you kind of dodge out your dots when there's like different fills or more than just X and Y. All right, so there is our box plots continued. So now what I'll have you do is I have a quick test in Kahoot that actually right around here it should pop up that you can click that link and take that it's a quick assessment of what we've done, or you can, I think there should be links in the description below for that as well. We've made it to our distributable friends, the bar plots. Well, for histograms and box plots, which are typically summaries, they're pretty easy to create, like histogram X variable or box plot X and Y variable. Bar plots are typically presenting the results of statistical tests, which involve means and confidence intervals, so it takes a lot more calculations. So for example, the basic bar plot takes this much code. Yeah, that's a pretty big time investment for even the simplest bar plot, sorry. And so to call this basic is like calling an introduction to modern astrophysics a basic textbook. It's pretty intense. And so all this will give us a very simple generic plot here. And really, I'm not going to go into too much detail of what's going on, but essentially I need to format the data in a certain way, get means out from the two different groups, get lower limits and upper limits for the confidence intervals, create different data for X and Y, do a bar plot, and then create the bar plot and then create arrows so that it takes the confidence interval. So just a lot going on here. but you'll get a very messy plot. This is the type of, I think, transmission for cars, and then quarter mile seconds. Now, if you want to do the same thing in ggplot, it's a little bit easier, but it's still going to take a lot of work up front. So first of all, some of this work here can be simplified by using this some functions here. So essentially, you create a summarized data set. So this is the iris data, so I summarize it, I group by species, and then I can summarize and get like our mean, our standard deviation, error, upper and lower limits, sort of like we did here, only just in a little more condensed way. So then when I actually finally get to my actual ggplot part, I use my iris sum as the data, tell it my species, and now I called it mean, so my y variable is mean, and then fill by species. So in the long run, using this sort of format and starting to use ggplot exclusively is going to be a really big time saver in the long run, because even the most basic bar plot is actually even more work. Now, I use geometric function geombar, tell it stat identity, and then I can add with plus sign the actual error bars here, and that's just the statics. I use the lower limit and upper limit that we created here, and then I can set the width so they're offset a little bit, or sorry, the width of these. And then that's how you get that here. It's definitely a little cleaner, a little more going on than that one. Now with a two-way GG bar plot, very similar, but for your sum data set that you're doing with this code, you want to group by two different variables. So here it's wool and tension. Same sort of thing. You get mean, standard deviation, upper and lower confidence limits. Then your ggplot, same sort of thing here. Our x and y variable, and then we make a geometric bar. And now here, I'll kind of show this what we're working towards. In the bar, we're going to have a statics with our fill equals tension. So that's that fill. The fill, once again, is separated by color. Stat identity, once again, since we're having more than x and y, we want to set this position dodge. This will separate the bars out, dodge them out. And then when we do our error bar, we'll have to do the same sort of thing, get the lower and upper limit with one. But then we also want to position dodge, and it turns out here about 0.9 had it line up more or less neatly here. So bar plots, turns out they're actually a lot of work no matter what you do, but they're one of the most standard things that you'll need to make and present for results. So it's good to get a handle on them. So let's continue. Upgrade. Actually, the upgrades isn't going to be as bad as you would think, because we've already done a lot of the dirty work of getting the means and upper and lower confidence intervals calculated through our earlier steps. So for the upgrade, we're just going to use our bar plot, use the data we have. We're going to change colors here. I'll show you what we have here. All this stuff here is to deal with axes. We can set, now this is a little more complicated stuff. We can set the limits here, but then if we want to set our own axes, like do every sort of little thing to them, we can set our axes to false, and then in further lines, create our own axes. So this is the first one. We'll have side 1, so that's going to be our x-axis. So we're going to set it at x, and then create our own labels. So these are engine type, V-shaped, and straight. And then this is how we have our setup for size and position to axis. Our axis 2. So you can see here, you can either do the format of like side equals 1, or just put the first one 2 and then the comma. Either way, I usually typically like to do the first one to make it clear, but the code still reads it just fine. So the y-axis, set all our different points, then set some sizing and positioning, and then we'll set specific text. So for side 1 is our engine type, side 2, quarter mile time. And then finally we'll add our arrows. That's our upper and lower confidence limits. This just tells us where to put them. our length, so how kind of wide they are, our angle to make sure they're 90 degrees, and then code 3, I think, sets the type of end that we want. And then we'll create a nice little box around it. So more work here, but kind of a little more intelligible at this point. So with a bar plot in ggplot, we can do all sorts of things here. This is what we're pointing towards. Now, this is really where we can get into a lot of the really minute things that you might want to tweak on your plot. So let's get started. Here's our geometric bar plot. And first of all, I'm going to upgrade by adding the color black, so that the outlines will be black. And then an error bar. So those will have these error bars. And now changing our labels, changing our scales, and having our scale fill manual. So that's more like iris, because these are flowers, a little more flowery color. So that's all kind of standard sort of aesthetics. But now here's the big thing. A lot of times you want to show significance in your graphs. A lot of times like asterisks are one of those ways. And so say, because all these are significantly different from each other, we want to show that. One thing we can do is add asterisks and lines. And so we can see that, like, this top one here means that Setosa and Virginica are significantly different, you know, et cetera, et cetera. So we can create all sorts of segments and text that we want. So I created 3 different lines here, and really all you need to do is use this function geometric segment, tell it where to start on X, where to end on X, start on Y, end on Y. So essentially you need to point the X and Y coordinate of this and the X and Y coordinate of this, and it'll do that. And I did that for, 3 different things here, and it makes these nice lines. Then if I want text, so for example, asterisks, what I did here is I labeled them with an asterisk, and then I gave them a list, so of X's, 3 X's and 3 Y's. So at each of these sort of midpoints, it creates a asterisk, and there we go here. And then I bump the size a little bigger. So this is a really nice way to like fine tune like exactly what and where and what you want. So it's great. So here now we have our two-way bar plot, and here I did a little something different. Since we have these more categories, is often you'd run something like ANOVA and have Tukey's t-test and kind of get the difference in groups, and you tell the difference in groups by letters. So for example, here we have A, which is significantly different from all these other ones, which are B. So to do this, we can do that, and this is a little different way to do it. So most of these things are pretty standard, change color, scale, whatever. But then what I did here to get these texts, I did this geometric text, and I had our list of A's and B's. And then I grouped them by tension because the bars are grouped by tension. And then this is the real crux of what's going on. Is V-adjust is it adjusts how far off from these mean values are. And so -5 means that they go up. And so you can tweak these around. So -5 gave it, so like this highest one, A, is far enough away that it doesn't overlap the bar. 6 would be a little bit higher, so I thought 5 is good. So these are something you have to tweak yourself. Size makes the size of the letters, so that's good. Again, we need this position dodge to essentially match the position dodge here, because once again we have not just one category but the 2 categories, so we need to dodge them, otherwise they line up on top of each other. And then a final little thing is I made this horizontal line by this geometric function geom_h line. They intercept 0, and then I finally added this theme classic, which kind of made the background nice and white and not any of those like kind of shading and grids. And this reference lines here is kind of nice just to base it on 0. Okay, those were our bar plots. So I've created a little animation summary that will kind of transition into to kind of give you an update or a review of what we've done so far. Whew. All right, we are back, and thankfully we're done with the bar plots and on to a little bit easier now, scatter plots. To do a basic scatter plot, it's actually quite easy. Basic. I like to use again this sort of function or equation notation where y variable is a function that tilde of x variable, and that'll give us simply a very nice scatter plot here. Now, if you want to do some ggplot, not too much harder. This first step here isn't actually ggplot. This is creating variables of log brain size and log body size because I want to do log variables. And all we just do is our ggplot, as we've seen, data, our aesthetics, so x and y, and then just this geometric function geom point. And that'll give us just a nice little scatter plot here. If we want a two-way scatter plot, we'll use this crab dataset. Now all we need is x and y. And then we want to fill, like we've seen before, and then also color. So it tells us that we not only want to fill it, but we want to color it by sex. And that gives us, with the geometric point, a two-way bar plot with female and male crabs. And then this is carapace length and I think carapace weight. So pretty simple. But we, of course, can jazz things up. So in the basic scatter plot, a lot of these things we've seen already. We can set our limits. We can set our axis to false, so we can create our own axes. Right here, I'm going to set our x and y labels to nothing, so I can create my own later. And then these are some variables that we can use to change the dots. Then we have the kind of the shape of things. So this is how you change the shape of them for the dots. So these are filled circle. 19 is like filled circles. Color, make them black, and then the size. So create my own axes. So from 0 to 120, and then from 0 to 25. Create my own labels, speed, and stopping distance. So these are for cars. And then create a box after I've created my plot. And then I'm going to add a line. So there's a couple different ways to add line. What I like to do here is the line is essentially the linear regression best fit line. So you can just do something like linear model and then our equation, car speed as a function of distance, and that gives us our line there. So a lot we can do to upgrade in ggplot. So this is what we're looking at here, and I'm just showing all sorts of things you can do. So first of all, some things here outside. I create this data frame. This is just going to be useful for creating this circle. I just create an x and y variable to be able to access later. So the main thing here is I have geometric point, creates a scatter plot. Then I want this horizontal line, so I just do horizontal line, intercept of 0. I'll get that nice line. Then geometric smooth, that's how you can get this line here. And you want to do linear model, so it's just a simple linear regression. And then I color it by red, so that's great. Then I think by default, then it creates these this confidence band. Then create a classic theme to make the background clear. Labels, once again, x and y, pretty standard. Set my limits of my scale, my axes, standard stuff. So now this geometric point. This is a way to make a single geometric point. So we're going to use our dataset circle. So x and y is these things, and then size is going to be 4, so there's going to be a really big point, but then shape is 1, so that's actually a hollow circle or a unfilled circle, and then colored by red, which creates this giant circle here. So the x and y are essentially the origin coordinate, and then the size is so big that it zooms out like that. And then I could add some text, because the reason I put the circle there is like, well, maybe these are outliers, so do geometric text, tell it where to put it, and size it and color it. There we go. So there's a lot you can do with this. Here's some great examples. Two-way scatter plot is going to be a little more conventional. We're going to have, first of all, I'm going to do this summary linear model. This is essentially I'll use later. It spits out some results of a regression that I don't show here, but I'll reference. So what we're looking at here is, it turns out you can do a lot more than just two-way. This is actually kind of like a three-way scatter plot. Anyways, but I'm going to make geometric point. That should give me my base plot. But then I'm going to now here have color and shape. So color by species and shape by sex. So I'm actually two different categorical variables. Do my geometric point, make the points a little smaller because we're doing more with them. Set my, of course, my labels. Then my scale color manual. So I'm going to color because I have blue and orange crabs. So I'm going to color them by blue and orange. And then set the values. So they, the labels look nice. Instead of B and L, it's blue and orange in the values. And then now I can, because I have shapes too, I can set my shapes as well. So I'm going to call them female and male because that's what they are. And then the values from there. Then, and these values being 4 and 16 being the types of shapes. So 4 is going to be these like X shapes for female, and then the 16 again we see is that filled circle. Then we're going to add a line here. Now, earlier we added a line with geometric smooth, but we can use this geometric add line. We can set our own line if we want. So if we give it an intercept and a slope, it'll give us a line. So what we did here is we did the summary here, which will give us an intercept and slope, which turns out to be 1.09, 1.11. We can manually fill them in here if we really want to, which I did here. And then create a classic theme, and then set this guide so it kind of cleans things up a little bit. So there we go with scatter plots. So I've got some more exploration for you here, which again is prompted in the R code available. So why don't you try building your own mock data and creating a graph with it. As you can see here, a lot of times there's times where I'll just like create data sets, and so you can learn how to create your own to be able to play around with like testing graph creation. So try that out if you have time. All right, now we'll get into the other plots category. So I thought it would be important to look at spaghetti plots, logistic regression plots, and then bubble plots. So spaghetti plot, also known as like a line plot, in ggplot, all we need to do, tell it our data. We want an X, a Y variable, and then a group variable. And so we're going to do that, and then we do geometric line, and this is what it gives us. So we have our X, our Y, and then our ID is these different lines. It's pretty simple. Let's look at logistic regression, which is different from linear regression, where the Y variable is a binary, like a 1, 0, yes, no sort of thing. So we're going to set up some data, get a log variable. Then we're going to do this here. Really, it's similar to scatter plots, where we need an X variable and Y variable. That's all we need. And we'll do geometric point. That'll plot the data here. So that's getting this stuff here. But if we get this nice logistic line, we want to use stat smooth like we've done before, but instead of a linear model, we need a generalized linear model. If we don't want those bands, we set the standard error to be false. And then this is the really big thing to get the right line, is method arguments, list, and then family binomial, which will give us this binomial distribution, which is the kind of the results for logistic regression. So there we go. That's that. Not too terribly painful. Let's get into bubble plots, which is typically looking at 3 or more numerical variables, maybe a categorical variable. So what we'll do here is we want our cars data set, and then X and Y, and then now here, instead of something like group or fill or color, we're using size. And we make a geometric point, and so we're going to have a different size based on that. So we have engine size and the X, RPM and the Y, and then our size is horsepower. So of course we can upgrade these, so let's do that. First of all, spaghetti plot. By now a lot of these things are pretty standard, we've seen before. Now that we had our group ID, but now we actually want a color as well, so we'll also set our color to be ID. So when we get them out here, we see either each ID, each group has a different color. We can change the size of the lines, make them a little thicker. We can set our legend to none, so we don't have like ID 1, 2, 3, 4, 5, 7, 9, and 10 for each of these, which isn't really helpful and informative. And then change our labels, of course, change our scale. And one thing we can do here, because that first graph was a little kind of squished, we can do this expand, make these decimal, which will shoot these up. So now this before and after, they're kind of farther out than they were before. So it kind of makes nice longer lines. Now, logistic regression, there's a lot we can do. So one thing we're going to do here, we'll start with our geometric points. So these points here, we're going to change the alpha so they're more transparent, because there's a lot of data sets. So it's nice to make them a little transparent to see kind of their overlap. And we're going to actually jitter them a little bit, which means they kind of randomly are jittered up and down to kind of spread them out a little more so we can see more of the distribution. Stat smooth, again, we've seen most of this before. The only thing we really changed was the color and the size, made it a little thicker and made it red. And then changing the labels and the scale, the axis, pretty standard. All right, with the bubble plot here is, like I said, you can even add categorical variables. So in addition to our size, we're gonna actually fill it. So again, fill, when you hear fill, think, oh, change in color, differentiate by color. You can do that here. We're gonna set our points here to be a little bit transparent as well. Change the shape a little bit so that they're, I think, these filled circles with borders, black borders. We're gonna set my fill, so this is a type of car, the fill, a customized set of colors I wanted here, and then have a classic theme so the background's a little nicer. And so we have engine size, RPM, and then horsepower is the size of the circle, but then the color is the type. Like compact cars are red, sporty cars are blue, and so forth. So you can present a lot of different data. And heck, even if you really wanted to, you could have a fifth variable and have it by shape as well, like squares and triangles, but that's a little bit much for that, but it's possible. All right, so I also have a Kahoot test that should be appearing up here, as well as links in the description to kind of assess your learning thus far. All right, so we've made it through. We're almost to the end here. In our closing, I'd implore you to try out our post test and then survey if you haven't already taken that. And as promised, I have a special treat for you. Buried at the bottom of the R code, example R code that I've made available, I've actually created a series of functions that allows you to pre-build graphs, particularly those bar plots. So I created a function called bar chart to sample, bar chart ANOVA, bar chart to ANOVA, so a t-test sort of bar chart, a one-way and a two-way ANOVA. And so those let you sort of customize and build graphs much more quickly, because if we saw with the bar plots, they took a lot of like calculation. So that makes things a little easier if you're making a lot of bar plots. And that's a great way to sort of get your feet wet into creating your own functions in R. And so again, you can find that at the bottom of the R code that I have made available. So with that, I will do a little summary of everything in this thing so far, and then some acknowledgments and references after that summary. Okay, here are references of things that help me as I build this or use this. And then finally, just for acknowledgements, I'm a part of the Dakota Cancer Collaborative and Translational Activity. Find this module useful, this talk useful, please reference us appropriately. All right, thank you, and I will hopefully see you in either the SAS or SPSS part of the talk.